All right, guys, so welcome to Chapter 3. Chapter 3 is all about solving systems of equations. This first section covers the graphing method, the substitution method, the elimination method. It also does a word problem. This should all be a review from Algebra 1. So I'm going to go through it very, very quickly, and then those people that just need additional help, you'll have to come after school or ask during class or talk to your team. All right, so the system is going to look something like this, where A, B, C, D, E, and F are numbers. We're going to solve that system, and when we write our solution, we're going to write our solution as an ordered pair, please. Fractions only, no decimals if that happens. And here we go. My suggestion to you would be to pause the video in a moment and try all three of these examples using the graphing method. And then I'm going to show all three answers at once. If you get all three answers correct, go ahead and fast forward to the next method of substitution. If you get something wrong, fast forward to that problem so you can hear the brief explanation. When graphing, you must use the graphing method. So I need to see your graph, regardless of whether you know the solution in your head or not. I must see a graph. When you're graphing lines, please use 3 points to create a line. So pause the video now and try all three problems, and then unpause to see all three answers. All right, so the answer to number 1 is -2, 0. The answer to number 2 is all points on the line. Or you could say infinitely many solutions. You cannot say all real numbers. It does not, that's not a true statement. I'll explain why once I graph it. And number 3 would be no solution. That's the only acceptable answer there. So here are the brief explanations. For number 1, the first thing you need to do is rewrite each equation into slope-intercept form. So solve for y equals mx plus b. I know you guys know how to do that already because you did it in our first week of school when we did writing equations of lines. So this becomes y equals -x minus 2. So I'm going to graph that line, which I also know you guys know how to do because of piecewise functions. So at least 3 points to make Mrs. Ingley happy. My suggestion would be that you might even want to do more points just because you don't know where these two things are going to intersect. I'll show you what I mean. The second line, again, divide both sides by 4. Make sure you do sharing is caring, so you're dividing that 4 into both things. So this becomes 3/2 x plus 3. I'm not going to go up 3 and right 2 because I run out of graph paper there, so I'm going to go down 3 and left 2, down 3 and left 2. At least 3 points, please. So now you're looking for where the two lines intersect. Again, this is why, I would encourage you to do more points because it's hard to tell exactly, especially as the numbers maybe get a little bit bigger, where these two lines perfectly intersect. So I can go up and left, up and left, up and left to make sure that that is actually my intersection there. If I wanted to check my answer, I would take this intersection point, -2, 0, plug it into the first equation. It should make it true. Plug it into the second equation. It should also make it true. If it doesn't make one of them true, you messed up, right? It's not the correct answer. All right, for number 2, again, rewrite these lines into slope-intercept form. When you do that, for the first line, you get 2x minus 4. So I graph that line. And then I go to graph the second line. And I'm going to use a different color just to emphasize our point. When you go to graph the second line, you very quickly notice it's the exact same line. You do not need to bold it or make it look any different on your test paper. You don't need to use 2 different colors. You would just look and see like a pencil, one single line, right? But what does this mean? This means where do the two lines intersect? The two lines intersect everywhere on this line. So that's all points on the line as an explanation. You could also say infinitely many solutions. Pick whichever one is your favorite. You cannot say all real numbers because this point out here is not a solution. It's a real ordered pair. It's just not a solution. So that's why we can't say all real numbers. And then number 3, the first one is already in slope-intercept form. So I'm going to graph that. The second one, when you rewrite it, it becomes y equals negative 2x minus 3. So down 2 and over 1. I've run out of graph paper, so I'm going to go up 2 and left 1. These two lines are parallel, right? Parallel lines have the same slope. They never intersect. So when I'm looking for the answer, I say, where is the intersection point? They never intersect. So therefore, you would say no solution, right? So these are the three scenarios that can happen. You need to show the graph for graphing method. All right, next up we have the substitution method. So my suggestion again would be to pause the video and then unpause and check both your answers. If you get them wrong, listen to the explanations. If you get them right, feel free to fast forward. Go ahead and pause and try. So for number 4, our final answer here would be 2, negative 7. And for number 5, this is a no solution. So now I'm going to explain how to do them. So for number 4, the first thing you want to do is isolate a variable. Get a variable by itself. So either x equals or y equals. Typically, we always look for the variable that has the invisible 1 in front of it. That one is the most likely not to have any fractions involved. You can solve for any of these variables, but a good suggestion if you're having trouble is to pick the equation that has the variable with an invisible 1 in front of it and solve for that variable. So I'm going to solve for y. I'm going to subtract 3x from both sides. And then I'm going to divide by negative 1. And I get this expression. I'm going to take this expression and substitute it into the equation I haven't used yet. So that bottom equation, and I'm going to put it in for y. So I'm substituting it in for y, hence the name substitution method. I need to put parentheses because I'm going to distribute. And then from here, you can distribute, combine like terms, and solve. Right, I'm going to just show minimal work here, skip some steps. I get x equals 2. That's part of my final answer, 2 comma something. I'm then going to take this x equals 2, and I can put it into 3 different locations. You pick your favorite one. I can put it into the first equation, I can put it into the second equation, or my favorite place is to put it into this boxed answer I had before. That is usually the fastest and easiest one to do because it's already solved for y. And so then you get y equals negative 7, and I'm always going to write my final answer as an ordered pair. If the letters are different, like this one, number 5, C and D, if you were to get a solution, you would put them in alphabetical order. Okay, so number 5, I'm going to find the variable with the invisible 1 in front of it, and that's the one I'm going to solve for. So I'm going to add 2d to both sides. This is my expression. Take that expression, put it into the other equation I haven't used yet. Distribute and combine like terms. So what happens when you do that is the 4d and the minus 4d cancel each other out, and the variable vanishes. When the variable vanishes, you're going to be left with an equation with 2 constants. You either have two choices here. It's either a no solution answer or it's an all points on the line answer. If this is a false statement, you say no solution. If that was a true statement, you would have said all points on the line or the phrase infinitely many solutions. All right, elimination method is the last one. So same thing, try each of these problems using that method. If you get the answers right, move on. If you get the answers wrong, listen to the explanation. Go ahead and try them. All right, so for number 6, you should have all points on the line. For number 7, your answer is 0, 4. Again, if the letters of the alphabet are A and B, and you did get an answer, you would put them in alphabetical order. All right, so Elimination method, our goal is to eliminate a variable, hence the name elimination method. So the first thing you would do is line up your variables vertically. So I'm just going to switch the order of that second equation so that the A's and B's are lining up vertically. And then what you want to do is multiply one or both equations by a number so that when you distribute that, either the A's or the B's will cancel. So I see that -2 times 2a would become -4a, and that will cancel with the bottom equations 4a. Make sure the most common mistake is that when you multiply, you forget to do it to all three things, not just the first two terms. I'm keeping the second equation the same, and now I notice that my A's cancel. Interestingly, for this question though, everything cancels. So when the variables cancel, you're left with an equation that has just two constants in it. And like we just said in the previous problem, when this happens, it's either a no solution problem or an all points on the line problem. And because here you have a true statement, 0 does equal 0, it's an all points on the line answer. If those two things canceled, and let's just pretend for a second that this number was different, let's pretend it was an 8, and that didn't cancel, now you would have a false statement, and so you would say no solution. Okay, number 7. Number 7 is a little bit tricky because 9 and 15 are not multiples of each other, so there's no one number you can multiply by them to cancel them. Same thing with 8 and 10, they're not multiples of each other. So it's a little bit harder to see what you can multiply by. Worst case scenario, you can take these numbers like 9 and 15 and just swap them, and then make sure, because this would be positive and positive, just make sure that you make one of these things negative. This way that they're inverses and they cancel each other out. What I like to do is just keep the numbers as small as possible. So I look at the 8 and 10 and I say, okay, 8 and 10 have a least common multiple of 40. So I can multiply 8 times 5 and I can multiply 10 times 4, and that would get me 40y on the top and 40y on the bottom equation. I can't have 40 and 40, one of them has to be negative. So I'm just going to make one of these numbers on the outside a negative, so I'll do -5. Now I'll have -40 and +40, and that will cancel. I have to multiply every number in the top equation by -5, so that would become -45x minus the 40y equals -160. On the bottom, 4 times 15, and then 4 times the 40, right? So the variables y cancel, that's the goal. And again, I chose -5 and 4. You could have chosen a different set of numbers, that's fine. As long as you have a variable that cancels, whatever you chose is fine. So now I add my x's together, that's 15x. This side cancels. That doesn't always happen. In this problem, I wanted to do that to show you a little bit tricky. People tend to think that if that cancels, it's automatically no solution, right? Or all real numbers. But we still have a variable, right? The variable is still here. We can keep solving for it. So we're going to divide both sides by 15. 0 divided by 15 is 0. Now, I'm going to take this answer and go plug it in to either the first equation or the second equation. It's your choice. So I'm just going to put it into the first equation and then solve, and you would get y equals 4. And so my final answer is 0, 4. All right, last thing we're going to do is a word problem. So you're going to write a system of equations and solve it using any method you want to. I don't recommend graphing method, so substitution method or elimination method. Make sure you set up the system and then show all your work to solve it. So go ahead, pause the video, read the question, try to solve it, and then I'll show you the answer. All right, so the final answer, make sure you do not answer it as an ordered pair this time. When we're doing a word problem, we want to answer the question, how many of each kind of ticket were sold? If someone asked you that question, you wouldn't say 33, 84. Right, so make sure you answer it like a real human being would. Okay, so 33 children tickets and 84 adult tickets were sold. The setup of this equation, let me get rid of the red. The red's so red. Setup of this system, you would need two equations. 1.25a, I'm using A for adult ticket, plus 0.75c, C for a child ticket, 129.75. That explains that the price of a adult ticket, however many you sell, plus the price of a child ticket times however many you sell, would give you the total number of what you make from those sales. So that first equation is all about money. The second equation would be A plus C equals 117. This second equation is all about how many tickets were sold. The number of adult tickets plus the number of children tickets has to add up to a total of 117 tickets. So this would be your system that I need to see. So when I'm grading, I will give you credit for the two correct equations. If you would like to, you can take that first equation and just move the decimal point 2 to the right, and that will get rid of all of the decimals. You just have to make sure you do it for every single term in that equation. So you could use this instead, and that avoids all the decimals. So choose your method of how to solve this. I'm a fan of elimination method. That's what I usually use, but you can do whatever you want to, and you would get this final answer. I'm not going to show the work. If you needed me to help you find a mistake, let me know. Right? So this is all of section 3.1. Hopefully it's all just been a giant big refresher for you. If you have questions, make sure you write them down and bring them to class. Thanks, guys.